Okay, this is the pretest quiz for acids and bases. So here we go. This first section, number 1 and number 2, are figuring out your strong acids and bases. So in the first one, you need to label strong and weak acids and bases. So here we go. HBr, strong acid. H3PO3 is a weak acid. And hydrofluoric is a weak acid. Okay, so all your binary acids are going to be Br, Cl, and I. Okay, those are all your strong acids, and because they all have hydrogen, these all should be acids. Calcium hydroxide, this is one of your strong bases. HNO2, this is a weak acid. H2SO3 is a weak acid. SO4 would make it strong, but SO3 is weak. Copper hydroxide is a weak base. OH makes it a base. Aluminum hydroxide, weak base. And perchloric acid is a strong acid. Okay, so that comes from your list. If you don't have that list, come see me. According to Arrhenius theory circle, it's classified as a base. So we're looking for all of your bases. So an Arrhenius base and a Bronsted-Lowry base, they were all, even though Bronsted-Lowry has increased what we know as a base, they still include all of these, just like the acids. Okay. Now, because this is an Arrhenius, we're only looking for the ones with OH in them. We've talked about NH3 being a base, and it is, but this is a Bronsted-Lowry base because it does not have that OH. Okay, so Bronsted-Lowry will be all of these, but it also includes this. An Arrhenius base will only have the ones with OH. The same thing with the acids. Arrhenius acid, an Arrhenius acid will have all of your H's. A Bronsted-Lowry will also have all of your H's, your hydrogens, but it will include a few others that don't have those H's. Okay, we skip number 3. So down here on this box, we need to figure out all the mixing things by what's given to us. All right. So if we start with, let's say, this one. If this has a pH of 7, remember this pH plus pOH has to equal 14. Okay. So 7 plus 7 will be 14. Okay. If I take my next column here, take 14 minus 9.4, 4.6 will be the pH there. Okay. Now, some other hints. Because these are whole numbers, we can very easily go over here and say, okay, pH matches with the hydronium ion, 1 times 10 to the negative 7th here. Because that's a whole number, 1 times 10 to the negative 7th there. If we use that same trick in reverse, well, this is 1 times 3, which means this has to be a 3. If that's a 3, this has to be an 11. And if that's an 11, same trick as we went from here to here, 1 times 10 to the negative 11th. Okay? Where those tricks really don't work is when we don't have whole numbers or when our coefficient is not a 1. So here we actually need to calculate. So I'm going to use this row to calculate for my hydronium and this row to calculate for my hydroxide. So when I'm going from a pH into a concentration, the concentration of anything equals 10 to the negative pH, or if I'm using over here, it'll be 10 to the negative pOH. So because I want to get into my hydronium, I'm going to take 10 to the negative 4.6. Here we go. 10 to the, 10 to the negative 4.6, and put it into scientific notation. I should get 2.51 times 10 to the negative 5th. Same thing over here, 10 to the negative 9.4 should be 3.98 times 10 to the negative 10th. Okay, so start over. And now, because I'm going from a POH into a POH, concentration of hydroxide into a POH, I'm going to be using the negative log, so I'm going to get back into my normal function out of scientific. And so now I can go negative log, put that number in 2.3 times 10 to the negative fourth, and I should get 3.64 times 10. Oh, I'm sorry. No. Just 3.64. 3.64. Okay. Then I'm going to take 11 minus 3.64. Sorry, not 11. 14, because the pH plus pH equals 14 minus 3.64 equals 10.36. Then when I put that into this formula, I should get my concentration of hydrogen or hydronium, same thing. 10 to the negative 10.36. That comes out to be 4.37 times 10 to the negative 11th. Okay? So over here, acids and bases, it's easier for me to look at your my pH scale because I'm used to it. So all of your lower numbers are going to be acids. So this should be an acid. That should be an acid. Your higher numbers above 7 will be a base. If they're right at 7, that is going to be neutral. Okay. So down here at the bottom, what is the concentration of hydronium of a solution whose pH is this? So real quick, some things to watch. This comes from an acid is the concentration of hydrogen, and we're in the pH scale, so those things match up. That's a good thing. If they didn't match up, we'd have to do some converting. Okay, but because they match up, I can use this formula because pH is given. I want the concentration. That's what this formula is giving me. So I'll be using this with a negative pH, 10 to the negative 9.8, 1.58 times 10 to the negative 10th. Okay. Number 6, find the pH. Let me rewrite the pH equals negative log